Hello everyone. We do static question solutions. Our topic, two-dimensional force systems. Our question, replace the force system consisting of four forces applied to the beam in the figure by a force couple system at O. Now, before solving this problem, as always, I recommend you to pause the video and understand the problem and think about how to solve it. Let's move on to solving the problem. Let's examine the problem first. We have four forces. We have a force system consisting of four forces. It seems that these four forces consist of two couples. One of the couples consists of 8 kilonewtons forces. The other couple consists of forces of 2 kilonewtons. We know that the resultant of a couple is 0. The resultant of two couples is 0 in total, again 0. So when we reduce it to the point O, there is no resultant. Wherever we reduce it, whether we reduce it to another point, the resultant never happens. The moment of a couple about all points is the same. So it doesn't matter whether we reduce it to point O or to point A. The moment about all points is the same. Since the resultant of the couple is 0, the resultant of this system is 0. Now let's find the moment. The total moment of this force system is equal to the sum of the moments of the two couples. Since the moment of a couple is the same about any point, I can take moment about point A instead of taking moment about point O. Let's first find the moment of the 8 kilonewtons couple with about point A. A force of 8 kilonewtons passing through point A, it does not create a moment. A force of 8 kilonewtons, whose line of action passes through point B, creates a moment about point A. I will use Varignon's theorem to find the moment about point A of the 8 kilonewtons force passing through point B. I will shift the force on the line of action and bring it to point B, resolve it into two rectangular components, and make use of the principle that the sum of the moments of the rectangular components is equal to the moment of the resultant. The horizontal component of the 8 kilonewtons force at point B creates a counterclockwise moment about point A. Therefore, it creates a positive moment. 8 sine 45, 0.3. The moment of the vertical component of this force about point A is in the clockwise direction. Hence, it is negative. 8 cosine 45, 1.5. The total moment was minus 6.79 kilonewton meters. Let's move on to the other couple. The other couple consists of 2 kilonewtons forces. The moment of this couple about point O and the moment about point A are the same regardless of where we take the moment. So I take moment about point A. Again, I take moment about point A. A force of 2 kilonewtons passing through point A has no moment about point A. The other 2 kilonewtons force will have a moment about point A. I shift it to point B and resolve it into two rectangular components. Once again, I make use of the Varignon theorem. Its horizontal component creates a clockwise moment, creating a negative moment. 2 sine 30, the moment arm is 0.3. So moment is minus 2 sine 30, 0.3. The moment of the vertical component, it's also clockwise. So it is also negative. 2 cosine 30, moment arm is 1.5. Total moment minus 2.9 kilonewton meters. This is the moment of the second couple. The moment of the entire force system is found by adding these moments. In plane force systems, since the moment vectors are perpendicular to the plane, they are all parallel to each other. The magnitudes of the parallel vectors can be added by considering their directions with a minus plus sign, and the magnitude of the total moment can be found. This is how we do it here. We do the scalar operation. We find the total moment by adding their magnitudes. We find the magnitude of the total moment. It was minus 9.69 kilonewton meters. This sign indicates the direction of the moment. That means it's clockwise. Yes. When we reduce the force system to point O, we're left with R and M. We have found that this R is 0 and M is minus 9.69 kilonewton meters. Now let's solve it by assuming that we can't see that this force system consists of couples. Let's reduce the forces one by one to point O. I choose that point as the origin. I'm assuming the xy axis pass through point O. Let's first reduce the 8 kilonewtons force through point B to point O. When reducing a force to any point, we carry the force as it is, without disturbing its direction and magnitude. But in addition to this, we place and apply a couple. What will be the direction and magnitude of the moment of this couple? The direction and magnitude of the moment of this couple will be equal to and in the same direction as the moment of the force about the reduction point. So I find the moment of the 8 kilonewtons force about point O, minus 18.67 kilonewton meters. While finding the moment of 8 kilonewtons force about point O, I again use Varignon's theorem. I shift the 8 kilonewtons force to point B and resolve it there into two rectangular components. Its horizontal component passes through point O. It does not create a moment. Only the vertical component creates the moment. The moment of its vertical component is also clockwise, hence negative 8 cosine 45. The moment arm is 1.5 plus 1.8 meters, that is, 3.3 meters in total. The moment of 8 kilonewtons about point O is minus 18.67 kilonewton meters. This means that the moment of the couple we will put into the system will be this much. Let's move on to the second force. Again, let's reduce the 2 kilonewtons force passing through point B, this time to point O. We bring the force as it is and apply it to the O point. But again, we add a couple, as we always do. In order for the effect of this force not to deteriorate for this system to have the same effect, I also use Varignon's theorem when finding the moment of a 2 kilonewtons force about point O. I shift the 2 kilonewtons force to point B, where I resolve it into two rectangular components. Its horizontal component passes through O. It does not create a moment. The moment of the vertical component is equal to the moment of the 2 kilonewtons force. The moment of the vertical component is clockwise, negative. The moment arm of the vertical component 2 cosine 30 is also 1.5 plus 1.8 meters, so 3.3 meters. Thus, we have found the moment of the 2 kilonewtons force about point O, minus 5.72 kilonewton meters. Let's move on to the third force, the 2 kilonewtons force acting on point A. We will reduce the 2 kilonewtons force acting on point A to point O. We will move it to point O. We take the force as it is to the O point, apply it, and add a couple to the system. The moment of this couple is equal to the moment of the 2 kilonewtons force at point A about point O. I also use Varignon's theorem when finding the moment of the 2 kilonewtons force at point A. I shift it to point A and resolve it into two rectangular components. I'm summing up the moments of the rectangular components. I have found the moment of the 2 kilonewtons force. It was also 2.82 kilonewton meters. Let's move on to the final force, the 8 kilonewtons force acting on point A. I carry this force to the point O as it is. But what should I do? I need to add a couple. What will be the moment of this couple? It will be equal to the moment of the 8 kilonewtons force at point A about point O. I resolve this force into two rectangular components by shifting it to point A again. The sum of the moments of the rectangular components is equal to the moment of the resultant. Varignon's theorem. We often use the Varignon theorem if you are aware of it. Done. We have reduced all forces to point O. Now let's add up these forces and moments and find their resultant. Firstly, let's add forces together. When we examine the figure, we see that the forces in the direction of each other are equally in the opposite direction. Therefore, they cancel each other out. The resultant of this system, the resultant force, is 0. R equals 0. Let's add the moments of the couples. Some are positive, some are negative. These are all parallel to each other. That is, all moment vectors are perpendicular to the paper plane, parallel to each other. So we can sum them as scalars. We consider their directions with plus and minus signs. The negative ones are inward from the paper plane, the positive ones are from the paper plane towards us. With the right-hand rule, we can see the directions of these vectors. When we add the magnitudes of these four vectors, we find the magnitude of the total moment. It was minus 9.69 kilonewton meters. So this moment was clockwise, the total moment. We show it in the figure. The resultant moment, the resultant couple moment, is minus 9.69 kilonewton meters. You know, this moment is the couple moment. Actually, we have two forces left. It does not matter in which direction and at what magnitude these forces are, or what is the distance between them. It's the moments that matter. Therefore, we denote the couple with the moment symbol. Goodbye.